Hello, hello. Here is our last installment of our 10.2 notes for comparing means. So today we're going to be talking about two sample t-tests for the difference between two means. So this is the box that appears on your notes. Same thing we've been doing, same thing from chapter 9. Still have to meet our conditions. We'll talk about that when we do an example. Still finding p-value. Still coming to the same type of conclusion, right? P-value's low, H sub O's got to go. The only thing that's new, writing our hypotheses with differences, and then our way to calculate our test statistic, right? In this case, our t statistic. Now, when we do proportions, we do z statistic. Now, there is a formula for z statistic, but the only way you can do that is if you know the population standard deviation, which, since we're inferring about the difference of means, we're almost always going to use t because we rarely know the population standard deviation. So this is here. I'm showing it to you. Isn't it beautiful? We're never going to use it. So let's look at our first example. In commercials for Bounty paper towels, the manufacturer claims that they are the quicker picker-upper, but are they also the stronger picker-upper? Two AP Statistics students, Wesley and Maverick, decided to find out. They selected a random sample of 30 Bounty paper towels and a random sample of 30 generic paper towels and measured their strength when wet. To do this, they uniformly soaked each paper towel with 4 ounces of water, held two opposite edges of the paper towel, and counted how many quarters each paper towel could hold until ripping alternating brands. For these data, the mean weight that Bounty could support was 117.6. For the standard deviation was 6.64, and then for the generic, mean was 88.1, standard deviation of 6.3. Is there convincing evidence that the wet Bounty paper towels can hold more weight on average than wet generic paper towels? So we're going to do a test to find out. So first step first, we are going to state. My paper up here. So we are going to test. So we're not estimating because it's not a confidence interval. So state. Is that a little blurry? It's okay. And our hypotheses are null, H sub O, comparing the mean, the true mean, notice how I'm using mu here, of Bounty minus the mean of generic. We're going to say that there is no difference. That's what we're claiming, that they're the same. But then we want to test it versus our alternative. And so we wanted to say if Bounty could hold more, which would mean that the mean of Bounty would be greater than the mean of the generic, which would mean the difference between the two would be a positive number, greater than 0. Okay? You also have the option to write it in a different way. You could say that they're equal to each other, like that, or that one is greater than the other. It's up to you, but you'll most likely see it this way in test situations, etc. So we want to test this at a significance level of 0.05 because they didn't tell me a significance level, so that's what I'm going to choose to do. Where, and now we need to define our parameters. U sub B equals the mean number of quarters, right? So that's how they figured this out, right? It was how many quarters each paper towel could hold. So this represents the mean number of quarters. That's a lot of quarters. 117.6. I'm kind of impressed. Mean number of quarters a wet Bounty towel holds. And then, do you hear my dogs in the background? And then mu sub G is going to equal the mean number of quarters a generic paper towel holds. A generic wet, I should say. Or a wet generic, same thing. Holds. Okay. So we've got our hypotheses, we have our significance level, we define our parameters. Good. So, state. Plan. What are we going to use? We'll use a 2-sample t-test for the difference of our means. So I'm using my parameters. If my conditions are met. So, first thing, check if it's random. If we look back in the problem, it says that they selected a random sample of each one. So, random sample of towels from each brand was taken. That's the word taken. We need to check normal. So because it's means, we either have to look at the sample size and see if we can use central limit theorem, or if we can't do that, we will have to check to see if the distributions look normal. That means that there's no outliers or skew. Lucky for us, in the problem, we took a sample of 30 Bounty towels and 30 generic towels. So that means we don't need to graph anything because we don't have the data anyway. So the central limit theorem works here, and we can assume that we can use T procedures. So, for normal, since n sub g is greater or equal to 30, and n sub b, so generic and Bounty, greater or equal to 30, central limit theorem applies. We can use T procedures because we know it's approximately normal. Last condition, independent. It says that we can assume that our samples were selected independently. So one will not affect the other. And then we also have to check our 10% condition because this was a selection. So we assume that there are more than 10 times 30, which is equal to 300 paper towels of each brand. So notice how I didn't say paper towel rolls, I said paper towels because that's what we're looking at here. So now we come to the math part. Okay. Just like when we did confidence intervals, we need to look for degrees of freedom after we find our test statistic. So T is equal to the difference of our means. So our sample mean for Bounty was 117.6. And our mean for, you can't do that. Our sample mean for Bounty was 117.6. Our sample mean for generic was 88.1. Minus, and then in our formula, it's saying the difference of our proportions, which come, or not proportions, our parameters, which comes from our claim here, and so the difference between them is 0. So minus 0 over, and then we've got to use big square root. Sample standard deviation for Bounty was 6.64 squared over 30 plus variation for generic, 6.30 squared over 30. Okay. So I'm going to put that in my calculator. Put that here. You see that? Yeah. So I've got 117.6 minus 88.1. So that's my numerator. Oh, that glare is bad. Yeah, that's okay. And then that's going to be divided by the big square root of 6.64 squared over 30 plus 6.3 squared over 30. And that gives me a test, or a, statistic of 17.65. So I've got 17.65. That's my T, my test statistic. Okay. So now I need to use that to find my p-value. Now, if I'm using my conservative degrees of freedom, I would just use n minus 1, which would be 29. Okay. Either way, I'm going to use my calculator then to find my p-value. So we want to find our p-value, and you can use your calculator now, just like we did for our confidence intervals. We're going to go to step number 4 and do a 2-sample t-test and find our stuff that way. So, in my calculator, over here, I go to stat, over to tests. That's not the one I want. So stat, tests, and I'm choosing option number 4, which is a 2-sample t-test. Now it asks me if I have the data, which I do not here. All I have are the statistics. So I have to enter in all my stuff. So 117.6, sample standard deviation 88.1, nope, that's not true. 6.64, 30, 88.1, 6.3, 30. We want greater than. We do not want pooled. It's only for proportions do we pool. And then we hit calculate. We see our T is really similar there. 17.65, 17.65. Degrees of freedom with the calculator is 57.84. So with technology, my degrees of freedom is 57.84. Now, for this particular example, it actually wouldn't really matter which one we use to find our p-value. If you'll notice, I know our p-value says 2.9, and then, where'd it go? There it is. E to the negative 25. That means it's basically 0. Basically 0. There's going to be 24 zeros after the decimal point and a 2. So our p-value here is about 0. Okay? So now we can come to our conclusion. So our p-value is definitely smaller than our alpha, so we're going to reject our null, which means we have enough evidence to believe that Downy wet paper towels can hold more weight on average than the wet generic paper towels. So there's our conclusion. I just wanted to put it up there so you can see it and copy it down if you need to pause this video to do so. If you are curious, can you hear my cat whining in the background? I'm doing this video at home. Tomorrow in class, you will be doing the examples that follow this, as well as on the very last page, figuring out when do we use what? When do we use a matched pairs, which we learned about in the last chapter, or a 2-sample t-test, which we just learned about today. Okay? Have a great day, guys. I'll see you all later.